I think. Yep. Okay. So looking at these, you gotta think about what the root is for each one of these. So there's not a number there, so that's a square root. So you're listening. So you gotta break the 18 down. So that is a 9 and a 2. 9 breaks down to 3 and a 3. So you're looking for a group of 2, right? So the only group of 2 that we have is those 3s there. So that means we get a 3 out front. Oops, I'm gonna leave some space. 3, and then we get an X out front. So I got the 2 still underneath there, an X still underneath there, and I get 2 Y's out front. That's it. That's all you have to do to simplifying that one. Yeah, not too bad for those. Number 2 gets a little bit bigger. So I'm gonna do it the same way. 64.
Question.
Yes?
Is it a y squared?
Yes, the y squared. Yeah, it's not a, I don't have the 2 in the root, it's the y squared. So 64, so 4 times 4, well it's 4th root now, we're looking at 4th root. 4 times 4 is 16, times 4 is 64, so we have to break this up in 2s to see what we get. So you got an 8 and an 8, those are 3 2s apiece. So we got 6 2s underneath there, how many you get out front? You get 1 out there because we're looking for a group of 4. So if we take this group of 4 right there, we get a 2 out front. We have 2 of them left underneath there, so that gives me a 4. And then R cubed still there. We get an S out front because we have a group of 4 of them. And then we get a T out front because we have 5 of them, and we have 1 left underneath there. One like that. Okay. Now, number 3 is probably a little bit harder. 3 and 4 are probably a little bit harder because you're going to have to rationalize. So, that one right there. We have to fix the stuff on the bottom. So we're looking for groups of 3. So, how many more 2s do we need to fix it?
1.
Well, we have 1 there. We need 3 total. We need 2 more. Because you're looking for a group of 3 numbers. Right now, the only thing you have down there is a 2. We need 2 more of them. So it would be 2 squared or 4. I'm just going to write 2 squared. Because that would give me 1 there and 2 more there. It gives you a total of 3 2s down. So we need 1 more A down there because we got 2 right there, and we need 2 more B's. So that's what we need to rationalize it. Okay, so it's cube root of 2 squared A B squared. Then you just multiply from left to right. Now this whole thing right down here on the bottom, that fixes to 2AB. Because this is going to be 2 cubed, A cubed, B cubed. And the stuff on the top isn't really going to simplify at all. So your answer is going to be, well, you can simplify with that when we're done. That's going to simplify with that stuff. So it'll be 2b cubed root of 4ab squared all over 2ab. So then that cancels with that cancels with that. If my marker would start going.
It's not like that.
Can you not multiply by 5?
Oh, I forgot that. So that should be 20.
So you only multiply that, not everything else?
Yeah, you only multiply the stuff underneath the radical.
This is not,
What's that?
this is not making sense.
They're kind of harder. Let me finish these last 2 here. So you got cube root of 20ab squared on the top of an A.
You should possibly, I don't know why they think I need
This is rationalizing here. This stuff right there. You have to figure out what you need to make that a nice cube root.
just in case.
Okay.
How do you get the 2B? Okay, the 2B stays.
Can I switch forward?
Yeah. You can move over here if you want to.
You multiply
The 2b stays where?
up front.
Yeah, that 2b right there stays out front.
So
That eventually cancels with what you have at the bottom.
X imaginary numbers of salt, right?
The 5 times 2 squared, so that's where the 20 comes from.
So you just take the cube root of 5 times everything else.
Yeah.
And now it's not that hard.
All right, next one, number 4, you're gonna have to rationalize again here. So 49 is 7 and 7, right? So you need another 7 down there. Well, we gotta break this up. So it's cube root of 9 over cube root of 49 x squared. So we need cube root of 7x.
So,
You guys see why we need a cube root of 7x? Because that's 7 squared. That means we got 2 7s down there. We got 2 x's down there. So we need 1 more of each. Okay, so this would make it a perfect cube. This stuff right here is a perfect cube. So that's going to simplify to a 7x on the bottom. Because this would be, I don't know, what is that, 243? No, it's bigger than that. 49 times 7 is a perfect cube of 7. X cubed is a perfect cube of x.
so anytime that you like try to,
Rationalize it?
yeah,
You have to
everything
get-
just cancels out and becomes.
Yes. On the bottom.
Yeah.
On the top, you have to multiply through.
Okay.
So on the top, this is going to be cube root of 63x.
That's it.
So your final answer is cube root 63x over 7x. Like that. That's it. Okay, last two here. And then we're going to get started on the lesson. So hopefully people can kind of follow these. I don't know. Once you do these ones, number 1 and 2 aren't too bad. You're just kind of looking for nice groups. 3 and 4, once you start rationalizing, they get a little bit more difficult. Okay, so number 5, we got f of x and g of x. Remember, you take the function on the inside, and that's what you're plugging into the one on the outside. So that means we're plugging this function in for this x. Okay? So we have 2x plus 3 is getting plugged into that x, so it's going to just look like that. So you don't want to distribute the exponent here because it's a plus. You just take that whole group, move it down to the bottom. So this is 1 over 2x plus 3. Oops. Because this plus right there does not allow you to distribute an exponent. The only way you can do that is if everything is being multiplied, not addition or subtraction. Okay? And then this
If
one,
that was a negative 2, then would it still be 1 over 2x?
if this was a negative 2,
Yeah.
then you would square the stuff on the bottom. You'd move it down and then square it.
So it'd be like 4x squared plus 9.
No, you have to FOIL it.
Oh,
It'd be 4x squared plus 18x
okay.
plus 9.
Is that more complicated?
No, we'll be doing that stuff eventually. Chapter 7 or 8 maybe? Chapter 7 is logarithms, chapter 8.
Oh, I'll be gone by then.
You'll be here. Alright, plugging G into F, so it looks like this. And this is the one that's a little bit more confusing. We had people doing this one yesterday, started moving the whole thing down to the bottom. So I plugged this stuff right here in for that X. Okay, looks like that. How do I fix this? What's this turn into?
Bring this down.
You bring the X down, that's it. Because the negative one doesn't go with the 2, it just goes with the X. Goes 2 over X plus 3. That's it. That's all you have to do.
So you cannot add the 2 and 3.
You cannot add the 2 and the 3 because your denominator for here is an X. Your denominator for here is a 1. You don't have common denominators. That's it. Domains of these, domain of this would be X can't be 0. Domain of that one, X can't be negative 3/2. Because remember, you solved the bottom of the factor. Okay?
How many points are going to be taken away if we forget to do that last part?
What last part? Simplify that?
No, like the,
Domains?
yeah.
You don't have domains on the quiz.
Really?
Really?
What about the test?
Yeah, some more papers.
Yeah, I do. There is domains. There are domains on the test, so that's like a point or 2. That's a point.
They get a half a point.
Okay, that's what we're starting with today.
My third notebook for this class.
Third notebook.
Well, you can't count the one that you had from intermediate.
I mean, kinda.
The ones on the worksheet are a lot harder than that.
Some of them, I think it probably seems like they're a lot harder because some of them are like really confusing. Where you have like a square root and an exponent.
Do you want this?
But you follow the same rules as everything else. Yeah, up here. Worksheet's due tomorrow.
I have to, oh wait.
You want it still for tomorrow? All right. So I want you guys to sketch these in your notes.
Why is this so hard? I actually did do the homework.
You did do the homework?
Yeah. I forgot I did it.
Yeah.
I didn't even know.
How did you forget that you did the homework?
I don't know.
This stuff is not too bad. Well, I don't think.
Those are like the bell breakers. Those are
No, technically, none of this stuff is that bad.
Yeah.
Really, no, it's not bad. Well, after you practice it for a while. Like the first time you see it, you guys are gonna be like,
It's gonna be bad.
the first time you see it after like trying 5 or 6 times, and you're like, man, why was I freaking out? That was easy. But that's kind of like a lot of stuff in math. Calculus, there's some things that are just hard.
See, I'm taking the basic math next year, and I'm done with it for the rest of my life.
Okay.
I wouldn't say that. Academically, I added the academically at the end of the year.
All right, so we're graphing square roots and cube roots. And we're graphing these with XY charts, but they're gonna be kind of XY charts where we have to think about what points we're using. So we're not using our predetermined -2, -1, 0, 1, 2. We have to use points that we're actually going to look at. So the graph of y equals square root of x looks just like that. Okay? And then the cube root of x looks like that one. This should look similar to what you guys have seen before.
Kind of have a short when it comes to stuff.
If I took my marker here and I kind of added that piece to it, what's it look like?
Wow.
Parabola kicked to the side, right? This is the inverse of that. We've done inverses, we did inverses yesterday. If I switch this stuff around and did the inverse, remember I'd have to add a plus or minus square root of x. It would be my parabola turned sideways. This one on the left here, that's the inverse of that one. We've done that before. Okay? If you guys think about domains of composite functions that we've done before, get rid of everything here. Domain of this, what do we say the domain of a square root is?
X
Equal to 0, because it starts from 0, right? Domain of this one? All real, everything. Because you got everything. It's going off to the right, off to the left. So if I were to make an XY chart, we're just going to do an XY chart for the one on the left, because we'll do it again later. To actually graph this, if you did like a -2, would it work? No, because we said our domain is greater than or equal to 0, right? What if we did 2, square root of 2? You guys know what that is off the top of your head. Square root of 2 is not a 1. 1 times 1 is 1. Square root of 2 is like 1.21 something. It's like 1.4 or something like that. I don't know what it is. So what about the square root of 1? What's the square root of 1? What's the square root of 0? What's the square root of 4? So what kind of numbers do you think you want to pick for that x? Perfect squares. Those are the ones you want to pick. So you would pick perfect squares. Perfect squares for your chart. For this one. What do you think you want to pick for this one? Perfect cubes, right. That's going to make your life easier when you're graphing these. So numbers that you want on your XY chart would be, since our domain is x is greater than or equal to 0, we want a 0, a 1, a 4. What's after 4 that's a perfect square? A 9. And I would say if you do 4 of them, you're good. You don't got to do any more than 4. 3 or 4 of them, so you get like a nice curve. So this would be 0, 0, 1, 1, 4, 2, 9, 3, because you're just taking the square root of that x point. So I could put my points on here. And 1, 1, 4, 2, and then 9, 3. Could be something like that. That's just your basic square root of x. Now here, perfect cubes, since we have all reals for this, for cubic functions, now you can pick negatives. So perfect cubes, you'd want a 0, a 1, and a negative 1. You'd want a, what else is the perfect cube?
2.
Not a 4, not a 2.
Well, 8.
8, right, you want an 8. And then what's the next number that we probably have to use? What's 3 cubed? 27. Those would probably be your 4 or 5 points that you would use. Okay, now we might have stuff added or subtracted underneath there, so we have to think about the numbers that will make them perfect cubes. Okay?
We do negatives for the other.
You can't do negatives for this one because it turns into imaginary. But remember, if you have a negative under a square root, it turns into I. Okay, this is the first one that we're doing, and we got to give domain and range now. We're doing domain and range.
So if you have something like that, cube 1, you can get negative numbers.
You can use negatives.
How come? Wouldn't that turn imaginary to you?
No, because it's cubed. If you have negative 1 times itself 3 times, that's negative 1, negative 1, negative 1.
Okay.
It's still a negative. Okay, so same kind of deal here. What number do we want to choose since it's a square root of x? We want, well, starting with your smallest one. That's a bigger one. 0. 0 is the small one. 0, 1. Okay, so for my chart, I want a 0. That's a perfect square. A 1, that's a perfect square. A 4, that's a perfect square. And a 9, that's a perfect square. It's not always going to be the same. So don't remember the 0, 1, 4, 9. Those are what we want the stuff underneath the square root to be. Okay, so that means we have 0, so 1/2 of 0 is still a 0. What's my next point? Square root of 1 is a 1. What's half of 1? Yeah, 0.5 or 1/2. Square root of 4 is a 2. What's half of 2? 1. Square root of 9 is a 3. What's half of 3? 1.5 or 3/2. So you can kind of see what your graph is going to look like compared to the last one. So I have 0, 0, I'll use a different color marker. 0, 0, 1, 1/2, 4, 1, and then 9, 3/2. So it's kind of like the same as the one that we just drew, but it's a lot more flat. And you guys can use Desmos to help yourself check these on your homework. You won't be able to use Desmos on the test, though. I think there's one of these on the test, where you have to graph it and state domain and range. Okay, not too bad so far. XY chart, we just got to pick nice points. This is all we're doing today, graphing these. Okay, we're probably going to graph 2 more by hand, and then we're just going to look at Desmos.
So would x be the main?
Oh, shoot, forgot that. Sorry. Where are we starting at? 0, where are you going from 0? Positive, so your domain is? Right, x is greater than or equal to 0, because we're going to the right of 0. Now, think about range. What's range stand for? If domain is x, range is y values. Where are we starting with y? 0, where are we going with y? Up. Can we go on forever?
Yeah.
Yes, all positives for that too. So domain is that, range is that.
Are we
That's,
ever gonna get asked?
yes. There's a question on the test and all the stuff on homework.
So if it starts like at a negative number, then it's all reals?
If it starts at a negative number, it would say you're starting there and you're going from there. So say if you had something that started back here, which is what we're going to be doing eventually. So say that's your first point. So where are you starting at? Well, x is greater than or equal to -4, because we're going to be going right of -4. So say our graph is kind of like that, just a little mini one.
So it would just be x is greater.
X is greater than or equal to -4,
Okay.
and then your range, we're down here at -4 here too, so your range is y is greater than or equal to -4. So it depends on where you start. Square root functions, you have a definitive starting point. Cube root functions, it's all real all the time. Yeah, let's graph the next two by hand, and then we're going to get Desmos out. So go ahead and graph that one. Cube root, so that means we can have negatives. Yes.
For cube roots, do we have to have 4 negatives and 4 positives?
No, I would say if you get 4 or 5 good numbers, you're good enough. So otherwise, you're going to be graphing numbers that are massive, because 27 is pretty big. So what do you think your starting negative number should be? No, not -3. We want to use negative numbers because it's a cube. Okay, we can use -1. We can use one that's a little bit, I guess, smaller than that.
Can you start with 0?
If you started with 0, you're only going to have the positive portion of the graph. It's a cubic, so we want the negative portion too.
So how much you just do?
You want to do both sides of the graph.
We didn't start. It would just be like
No, they're not B's. These are like sideways S's. I would start at -8. Okay? So I would do -8, -1, 1, and 8. Why do I start at -8? Because cube root of -8 is a -2. Okay? You could start at -27 because that's a nice cube root too, but I would start at -8. So this would be,
6.
yeah, 6. And then -1 is going to be a -1, so that'd be a 3. 0 is going to be a 0, and then,
-3.
right, -3, and then a -6. It should be symmetrical. I didn't even need to draw the massive points here. So graphing our points, we got 2, 4, 6, 8. -8, 6 is going to be there, and then -1, 3, 0, 0, 1, -3, and then 8, 6. 8, -6. So you can kind of see that my graph is going to go like this. And then this would continue on that way. Where'd you get lost? Because if I plug in a -8, it's -3 cube root of -8. What's the cube root of -8? It's a -2. because 2 times 2 times 2 is an 8, and we can have negatives. So negative 3 times negative 2 gives you that 6. Once you get to here, it's going to be symmetrical with stuff like this. If there's no pluses or minuses in there, underneath there, it'll be symmetrical. So domain is what? Looking at that graph. Infinity are all real. Okay, domain, and this is how I normally write that, just to kind of say, okay, domain is 1, I donate it or denote it with a capital D. Range is, it would also be all reals, because this is going to kind of keep going that way, keep going that way. All good. For cube root functions, both of them are going to be all reals, always. Okay. All right, last one here. I want you guys to write this problem out quick. Don't start your XY chart unless you think you know what you're doing. But we're going to do this one by hand, and then we're going to do the last few with Desmos. I need to put myself some graphs on there so I don't have to do that. Okay, so do we have square root or cube root function going on here? Square root, so that means we need numbers underneath there that are perfect squares. And perfect squares are going to be 0, 1, 4, 9. Yes? Yes. You saw that. What number can I plug in for x underneath here to make it a 0? 3. Not negative, it would be a positive 3, because it would be 3 minus 3. So your first x point is going to be a 3. Okay, I would look at what points we want to find first. So my next perfect square I want to find is a 1. What can I plug in for x here to make it a 1? Right, a 4 would be my next number. Now what can I plug in for x to make it a 4? 7 would be my next one. And then you say, okay, what can I plug in for x to make this a 9? It would be 12, right? 12 minus 3. Those are the points that you want to use. Does that make sense how we get those points? We have to look underneath the square root here. You got to look at that specifically.
What's the plus 2?
What's what?
That was on the end.
That's on the end. That's after we find our points, then we're going to plug them in and we're going to use that. So we need to define nice points or x, points for x to make it a nice square root. So if you plug in a 3, you get a 0. We know that the square root of 0 is 0. Okay? So that would give you 0 times a negative 2, 0, so plus 2, you get 3, 2 for your first point. Plug in a 4, you get a 1, square root of 1 is just a 1. So you got 1 times negative 2, which is negative 2, plus 2, so it's 0. Okay? That makes sense because this is a negative. If you think of our original functions, they went like that. This one's going to go like that. 7 minus 3, 4, square root of 4 is 2, times negative 2, that's negative 4, plus 2, so it's negative 2. And then 12, that's going to give us a 3 in our square root, so it's negative 6 plus 2, negative 4. So when you graph those points, so 3, 2, 4, 0, 7, negative 2, and 12, negative 4. So it's going to look like that-ish. Now our domain and range really changes here. Because it's not just greater than or equal to 0 again. Okay, I'll let you guys finish that here. Then we'll talk about domain and range.
So you add the 2 first?
No, you do times the negative 2 first. Because that's attached to the square root. So multiplication comes first. So you do your square root, multiply by a negative 2, then add 2. Okay. I don't know if you guys did these in intermediate. Did you do square root functions in intermediate? No? It's kind of like an educated XY chart. Like you just, it's not just -2, -1. Uh-oh, poster's falling. -2, -1, 0, 1, 2. You have to find numbers. You have to think about the numbers you plug in. Okay? So domain, where am I starting? Which x value do you start at?
3.
Start at 3. Which way are you going from 3?
Down. Up.
Well, you think left and right with x.
Oh, okay. Up.
So we're going that way from 3. So domain is greater than or equal to 3. Right? So we start at 3, we go to the right. Range, starting at what? Landon, where are we starting?
2.
Start at 2. Which way are you going?
We're going down.
Down. So that means y, because you got to use y for range, is less than or equal to 2. Because this says we're going below 2. Does that make sense? You got to look at where you're starting. That point tells you your domain and range. This starting point. That's it. Okay. So I want you guys to get out Desmos. I'm going to show you guys how to plug this stuff into Desmos. It's not too hard. It's pretty easy. But I'm going to show you how to do a cube root in Desmos. I put my iPad away. All right.
You put a cube in there.
Okay, so we're doing that function right there. So to do a cube root, you guys got it written down or not? You're just looking at it on the screen?
Yeah.
I'll have to go back to my deal there. So that's what Desmos looks like. You guys got it down. So it's 3. And to do a cube root, you got to go to functions. Okay, it's this little function deal above your arrows. And then you go to miscellaneous. And then you have this button. Okay, so again, miscellaneous and then the n root. Once you find that button, you click on it and it gives you that. So it's cube root. So you click a 3 and then you have to press inside your little box there. And it was x plus 4. So we got my x down here, plus 4. And then if you want to get out of this cube root, you got to click on the outside. -1. That's what the graph should look like. Okay? You can do whatever root you want with that button. You can do 5th root, 6th root, 10th root, 100th root, whatever you want. Okay, so then you would just, there's a few of them that you can do with Desmos. So what's your domain and range here? Cube root is what? So am I starting at any specific value? It's all reals, right? Because it goes to the left, it goes to the right. Is it all reals for range too? Yes, because we're going up, we're going down. So your domain and range is all reals. Okay? If you guys wanted to get some nice points to graph, you can click on it and it'll give you a decent point. And then you can say, okay, well maybe that's an okay point. And it should give you the, yeah, it does look okay. Gives you a decent point. Okay, so we like Desmos. Looks like that. We'll try one more. Or not. Or not. So that's your assignment. You got to do 3 to 5 by hand. And then 10 to 12, 16 to 19 you're going to graph in Desmos and just sketch it. Read directions. You need to do this. Give domain and range for all graphs. Okay? 18 minutes, time to do homework. Good to go.